this video we're going to learn how to differentiate the inverse trigonometric functions arcsine, arccosine, and arctangent. So if we have a function y equals sine of x, then the inverse, you just switch the x and y's, so it becomes x equals sine of y. And then we can find the derivative of this inverse using implicit differentiation. So we just differentiate both sides with respect to x, and we get 1 equals cosine y. And then since we need implicit differentiation, since there's this y, we add in dy dx on the side. So then dy dx is the derivative, so solving for that, we get the derivative is 1 over cosine of y. And then to simplify this, we can use the Pythagorean identity, which is sine squared of something plus cosine squared of something is 1. So if we solve for cosine y, we get cosine y is equal to the square root of 1 minus sine squared y. And then we can plug this expression in back to a equation, so we get that dy dx is equal to 1 over the square root of 1 minus sine squared y. And then if we look at our original inverse function, x equals sine of y, we can square both sides to get x squared equals sine squared y. So then we can replace the sine squared y with x squared. So finally we get dy dx, the derivative of this inverse of sine, is equal to 1 over the square root of 1 minus x squared. So we can use a similar method for all of the other inverse trigonometric functions. So, and then we get the derivative of arcsine is 1 over square root 1 minus x squared. We just derived that. And then the derivative of arccosine is negative 1 over the square root of 1 minus x squared. So it's the same thing as arcsine, but negative. And then the derivative of arctangent is 1 over 1 plus x squared. So now let's look at some examples. So we want to differentiate y equals arcsine of x cubed. So the outside function is the arcsine of something. And we just learned that if we have the derivative of arcsine of something, then it's 1 over the square root of 1 minus that something squared. So we take this something on the inside, which is x cubed, and we plug it into this spot over here. So first we have 1 over the square root of 1 minus, and then x cubed squared, and then from the chain rule we have to differentiate this inside something, which is 3x squared. So then we can simplify this, since x cubed squared is just x to the 6th. So next we have y equals ln of cosine. So again, our outside function is the ln of something, and we know the derivative of ln of something is 1 over that something. So we take this something on the inside, cosine, and put it here. So we have 1 over cosine x. And then from the chain rule, we have to then differentiate the inside something. And we just learned that the derivative of cosine is negative 1 over the square root of 1 minus x squared. And so our last example is y equals x squared times the cosine cubed. So to do this one, we have to use the product rule, since we have two things being multiplied, x squared and then arcsine cubed. So first I like to differentiate the first term and then leave the second term. So we have 2x times sine of arcsine x cubed, and then plus we leave the first term alone, x squared, and differentiate the second term. And to differentiate this term, we're going to have to use the chain rule, since we have two functions inside each other. So the outside function is just something cubed, and from the power rule we know that the derivative of something cubed is just 3 times that something squared. We just move the exponent down. So first we have 3 times the arcsine x squared, and then chain rule, we differentiate what was in the inside, and the derivative of arcsine is 1 over the square root of 1 minus x squared. So we put all of this in parentheses, and that's the derivative of this second term, arcsine cubed.